Hi guys, I'm Matthew, your VBA tutor. Today we're going to be building this. And yes, this is actually Excel. See? I wanted to find a fun project to teach some really important VBA concepts, like working with classes, collections, and basic object-oriented programming. Blackjack is a perfect fit. It's simple enough to follow, but gives us a great excuse to build real structures that mirror how professional applications are put together. And we have something fun to play with at the end. We'll focus on clean design while keeping it beginner friendly, and by the end you'll have a working game that you can actually play, plus a much stronger grasp of how to organise your VBA code properly. Now I'm aware that not everyone will know the rules of Blackjack, but that's okay. I'm just going to quickly go over the game so you can understand what we're building. In Blackjack, the goal is simple. You want to get as close to 21 as possible without going over. You're playing against the dealer, not other players. Each player and the dealer are dealt cards from the shoe. This is just a collection of decks shuffled together. In our game, we're just building one player and the dealer. Each card has a value. Number cards are their number. Face cards, like Jack, Queen and King, are worth 10, and aces can be either 1 or 11, depending on whichever helps your hand the most. If you're dealt an ace and a 10 value card right away, that's called Blackjack. It's the best possible hand and you win immediately. At the start of the round, you place a bet. You get 2 cards. The dealer also gets 2, usually one face up and one face down. You can choose to hit, which means to take another card, or stand, which is where you keep your current hand. If your total goes over 21, you bust, which means you lose the round automatically. The dealer follows strict rules with no strategy. They must keep hitting until their hand is at least 17. If they bust, all players who didn't bust win. Otherwise, the higher hand without going over 21 wins the bet. For this project, we're keeping it simple. None of the advanced features of the game, no splitting, no doubling down, no insurance, just standard hits, stands, betting, and the basic dealer rules. Now this is the full-length version of the tutorial, a complete sit-down session to build the entire game from start to finish. If you'd prefer it in shorter parts, just check the playlist for the episode-based series. Alright, let's get into it. First we're going to need some card images. I've just gone online. I've found a website called nikubunu.ro. The link will be in the description below. And I've just found a list of these cards. So you just download it as a pack, export it, and you get cards that look like this. It also comes with a bunch of card backs, so you can use these to create the back of the cards when we build our game. Anyway, I have all these cards and files already here. Just go and grab them, source them from wherever you like, as long as they have sort of a reasonable naming structure. Like this is C2 for 2 of clubs, and D3 is diamond 3. Okay, so first we're going to build a cards sheet. So this is just going to be basically a table with card ID, suit, card, and image. And we're also going to have a card back over here, and I'm just going to set all the height of these to 80 pixels to make it nice when we actually have our cards in here. Okay, so we're going to have hearts, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Alright. Copy that down. I'm going to do that again for spades. Again for clubs. And what's left? Diamonds. So, diamond. Okay, and then our card IDs, let's give them just increasing values all the way down to 52. We're also going to make this a table, so just click anywhere in this area and press Ctrl T to create a table, and then we'll just call that table cards. Over here I'm just going to copy this formatting. Let's make it look a bit nicer. And in here we're going to insert our card back. Now, if we just do insert picture, place in cell, what it does, it embeds the object, embeds the image object. We don't want that. We actually want to be able to refer to the image path. So what we can do is we'll programmatically insert all these images. So we go to the Developers tab, open Visual Basic, and let's just create a new module. We'll call that Mod Setup. This is only going to be used for setting up, just temporary to set up all of our card images. So we're going to do private sub, insert images, right? In here, we're going to specify a folder path as a string. Set the folder path equal to, and I'm going to specify this folder. Put the backslash in there as well. We want a file string. We also want to set the range of where we're actually setting all these values. We'll set range equal to sheet. We'll give that a code name, so sheet cards range, and we'll refer to the B column 3. That's just everything here down that column. Then we're going to loop through each of those cells. So we want to create a cell item. We're going to get the suit as a string and the card as a string. Okay, so for each cell in the range dot cells, we'll get the suit. So the suit's going to be lowercase, and the first letter of each suit name. So we're going to get H for heart, S for spade, C for club. And what we're doing is we're matching those names to the names here. So it's going to be C for club, D for diamond, so on. And then you'll notice these are 2 for jack, A for ace, 2 for 2, A for ace, J for jack, and so on. So in here we'll do left of the cell that we're on, because we're going through the B column, which is already the suits, and we'll get the first character from that. And then our card is going to be, we'll get the lowercase of that as well. It's going to be cell.offset. We don't want to offset by row, but we want to offset by column. So we're offsetting by 1 column, so that's, we're looping through these, and then we're getting this as the card value. Then the file name is going to be simple underscore, then we append the suit, another underscore, card, and their SVG files. Okay, so what that's going to do is create a string that says simple H for heart, 2 for card. That's going to be, simple underscore H underscore 2.svg, right? So then to insert the image the way we want, we actually need to select the cell first. Usually I don't like to select the cell, but because we're only going to be running this once, it doesn't really matter. So offset 0, 2, that's going to be, as we're again looping through this column, we offset 1, 2 to refer to this image column. And we select that. And then in the same cell, we do insert picture in cell, folder path, and the file name. All right, and that's all. So if I just do that and we run this code, there we go. So we've got all of our cards, nice images in there in each cell. And you'll notice that the file path is actually in the formula bar, right? If I do insert place in cell, and I do the same thing, you'll notice in the formula bar, it just comes up with picture. It's not as easy for us to reference later on in the code, so we're just going to use this one. like this. And we just need to do the same thing for the back. So private sub, insert back. And we make these just so that you can, easily change the cards if you want to. If you want to change the card faces or the card backs, then it's quite easy to actually change that. But these are just used for setup, so I wouldn't worry too much. The file path I'm going to use for the back of this in this backs folder. I made it previously with the red. I'm going to make it with the blue this time, so let's use that one. So copy as path, file path equals that. And then so we set a range object, set range equal to sheet cards dot range, and that's referring to just this cell G2. Actually, we might name that cell. We'll call that card back. Okay, and then we can just call that card back. Okay. And again, range select and range dot insert picture and file path. Okay, and run that, and you can see the card back appear there. Right. Now I'm also going to be using this card back image somewhere in the code, so I'm just going to insert that in over cell. Number 7. All right, so that's our cards sheet set up. Now we're going to create the game environment. So I'll call that game, and then in our code name for that, we'll call that sheet game as well. Okay, to set up the objects for this, we're going to do that in PowerPoint, but just quickly, I'm going to create a background. You'll notice in the original one, I had that sort of checkered pattern. We're going to insert that. So we'll go to page layout, background, from a file. And again, I've got this casino carpet. All I did was I went to Google and I searched for casino carpet texture, and I found this one. I think I might have darkened it a little bit, but you can find any texture you like. We'll insert that. Looks horrible with the grid lines, so we'll turn those off. And there you go. You've got a casino carpet. All right, before we jump over to PowerPoint, I'm just going to create a shape here. This is going to be a semicircle kind of shape. I want this to be about that big. I'm going to cut off that top in PowerPoint. I think that looks good. Okay. So we'll copy that. We'll head over to PowerPoint, paste that image in. Now, first thing I'm going to do is just trim off that top. So I think from about there, create another shape, then Control click on both, go to merge shapes and subtract. That gives us our nice semicircle shape. Now to make our border, we're going to copy that, and we'll go to hold Control and Shift and drag in that corner. That evenly drags in and centered on the same positioning. So we're going to create, that's going to be about our border. We're going to duplicate this because we're going to want, that's going to be the tabletop. And we're going to duplicate that because right at the very back, we're also going to want to create a shadow. Okay, so we'll click the larger image and then the smaller, and we'll do a subtract. So at the moment, that doesn't really look like anything. If I just get rid of front and back, you can see we now have this sort of outlined shape. So for the shape fill for that, I've got this brown color. Again, you can kind of do whatever you like for this. And I'm going to give it no outline. And then I'm going to give it a bevel. Let's have a look, see. I think that one looks good. That's slant. And then our inner shape, we're going to shape fill that with a sort of light green color. and give the border the same color. And then our shadow behind, we're going to just select that very back shape, go to shape effects, shadow, give it that outer shadow. And that's sort of the basics of our table. You can leave it like that if you want, but I'm just going to create another few little features. So I'm going to get that card back. That card back is going to be like our deck. We're going to give that a sort of drop shadow like that. It sort of makes it look like it's got a bit of height to it. And then we're going to duplicate that. We want that down here. We're going to make another shape, which is about the same size. This is going to be our sort of card placeholder. So I'm just going to make that same dimensions. All right. Our shape fill for that can be no fill or the green, because it's going to be sitting on our table. And then this sort of light green, very, very light green, nearly like a white lime color. And we give that a bit of a thicker outline. Sit that there and just get rid of that card sitting behind there. We also want to make sure that this is centered on the table. So we'll align, center. Again, you can leave this as it is for now, or I also just want to create a little cutout for the dealer's side of the table. So we're going to set that there, center it. Going to make that like a very dark green, like that, with no outline. Bump it up one position. And then we're going to copy that. I'm just gonna get a little bit smaller. It gives it like a bit of a drop shadow kind of effect. It's a bit darker. There we go. Then we give both of those an inner shadow. So kind of like that. And that's going to be our section for our dealer. I want to just make that a little bit like that. There we go. So now we've got our table. You can create any other little features you want on this. Maybe you can make some legs, or maybe you can make a little dealer person there, but I'm quite happy with this. I'm going to just group all that and copy that, and we'll go back over to our Excel document. I'm going to paste that on the carpet. So we want to get this centered sort of on the screen here, right? So I also have a bottom bar on mine. So what we'll do is we're going to hide the unnecessary columns. So I've got this scaled exactly how I want it. This AD, if I bring that in, now that's our limit. So if I highlight every cell, hold Control and just get rid of the selection of all those. That means every column across here is all selected. We can right click on that and go hide. If we do the same thing down here, so past row 40, hold Control, select all of those, deselect them all, right click and hide. So now we have our sort of game space. And we're going to put that down the bottom here. It's going to be our bottom bar. And we're going to give that a black fill, no outline. And then if we go to format shape, we can turn that transparency to about 50%. I think that's good. And then what we can do is use that to center this. So if you control click on that, then that, we got a line and a line center. And now our table is centered in the middle of the game. So now we're going to build out the rest of our interface. We're going to build all the buttons we need. We're going to create readouts for our players' wins, losses, ties, player balances. We're going to create a message box and all that kind of stuff. Down in the bottom here, what I've got in my game is I've got a cheats section. So the user can turn on cheats, and then they can see, information about upcoming cards and all that kind of stuff, which is just kind of cool to be able to turn on and off. But it's maybe not completely necessary, but we're going to sort of implement that as well. So for our buttons, we're going to create these sort of nice big circles. We're going to create, that's going to be like our hit button. I'm going to move that over a little bit and create another one there. And we can make sure that they're aligned. So these are going to have a nice thick outline, about 4. Our fill for that is going to be the darker color and then the lighter outline. Same in this for the red, so darker on the inside, lighter on the outside. So that's going to be our base button for all of our green things like hit, deal, and restart game. And then this one is going to be for our stand. But we want to give some text underneath those to identify exactly what the buttons are, because the images might not be that self-explanatory. So I'll just create a box underneath there. Again, we'll center align that. Give that no fill, no outline. And here we're going to just call this hit. Make that a bit bigger and center that. I'm going to leave the text white. Then we do the same for the stand button. So I want to make sure that they're in the same position, and that's aligned there, center, and call it stand. Now I might change the font for this. I used Daytona Condensed. We're going to use this sort of throughout the entire application, so that's the font I'm going to use. All right. Now we'll also have an icon in the middle of that, so we'll go icons, add a card button, we'll do add, like a plus symbol like that, bigger, and then we're going to make that white. Center that on the circle. The same over here, so center that. I'm going to change that icon to a hand, like so. Now we've got our hit and stand buttons. I'm going to group those. Group that as one button. Group that as another button. And let's copy that hit button. That's going to be our deal button as well. So we're going to change the graphic for this. For card. And we'll use this clubs card there and call that deal. Going to be our deal button. And then once again, we're going to create another button for restarting the game. I'll just make this one a little bit smaller. Change the icon again. That's for arrow. And I think this one. Use like this one or something maybe. That'll do. Okay. So if we go to the selection pane, you can see we've now got these buttons. I've just got to change it to restart. Okay. Now let's name these buttons properly, because these are going to be how we refer to the buttons when we're creating our items in the code. So we'll go, we'll call this one button restart. This is the deal one, so we'll call this button deal, hide that. This one will be button stand, and that one will be button hit. Okay, just going to name that our bottom bar, and that can be table. All right, now we're going to need a few more buttons still, so let's create, we're going to have some buttons over here that are going to represent our betting options. So we'll create a small button here. Obviously going to bring that text size right down, so I'll make that like a 10. I'll make it even still a little bit smaller, like that. The outline's too big now, so we're going to bring that back down, maybe like that. Text down, and change the text to, this is going to be bet plus $1. I mean plus $1. Wider. So we're going to call that button bet 1. All right, now for this one, I'm going to change the color. Let's make this like a fill can be a darker blue and a lighter blue for the outline. And we'll create another copy of that, make sure that they're aligned. And that's going to be our reduce bet. Change the icon for that one. Subtract, no, minus, okay, 1. And we'll give that circle a bit of a different color. So we'll go maybe dark orange and light orange, like that. All right, I'm just going to zoom in here a little bit more, and we're going to make some smaller buttons. About there, it's going to be +5. Not always going to want to jump up in ones, right? So maybe we're betting like $50 or something. You can obviously set these thresholds to whatever you want. I'm just going to use 1 and 5, and we'll set them back to that. All right. Last thing we'll need is a bet all button, I think. And when you're playing sort of not kind of that seriously, you probably just bet all your money sometimes. So we'll change that icon to like some coins or something like that. Coins, there you go. All right, I think that's looking good. Now we're going to have a readout here of what our bet is going to be. So I'm going to create shape here. I'm going to copy this for all of our different ones. So I'm just going to add a little bit of extra formatting to this. Make sure that our text box has no margins to it. And this is going to be our Daytona condensed. And text will make that the orange. I'm going to call that bet. Center that. Text a little bigger. Give it no fill and no outline. And we copy that underneath there. That's going to be where we actually have our betting amount. It's going to be obviously a bit bigger. Make that white. That's going to be, say, As a placeholder, we'll put $1, but we'll check, $100, make sure it fits in there okay. You can see that that might end up interfering with that bet all button, so I'll just move that bet all button up a little bit. And maybe we end up with enough money to start betting millions of dollars, so I want to make sure that there's plenty of space there. That's going to be our placeholder for that one. Then we're going to need the same sort of thing up here. That up above that actually. So this is going to be our player balance. Call that player balance. A little bit wider. And let's say our placeholder for that is $100. What these values are doesn't really matter at the moment. It's just sort of placeholder figures so that we can know what we're kind of looking at. Now, I don't think I made sure that those were centered. And with that, and I'm just going to make sure that they're centered on the table. Center like that. So they're going to be directly over the top of our card placeholder. Now we've got to name all those buttons that we've just created. So it's called bet 1. We'll call that bet -1. Small one, bet -5. Small one, bet 5. And we'll call it bet all. And we'll label these properly. So we'll call this bet label and bet amount, balance label, and balance amount. And we're going to copy those. And over here, these are going to be where we have our rolling score. I'm going to right align these ones. Left aligned. This is going to be wins. Total 0. Copy that. And again, we'll just group these so I can distribute them properly. I'll ungroup them in a minute. Now this one will be our losses, and this ties. Okay. Just select all 3 of those groups and distribute vertically. That means that they're all nicely sort of aligned there. Might give them a column each. I think probably looks a bit better. And then I'm just going to ungroup those because we want individually accessible. So label for this can be wins. This one, losses. That'll be ties. Now what else do we need? We need a hand size for the player. So we're going to put that and make sure that's centered on the table. I'll move that under here. Put that just underneath the table maybe, so we'll call that. And a new placeholder of 0. And we're going to need to do the same for the D. And center on the table. And we'll put his up in there. Smush it up a little bit. And I don't think that I've recentered those. There we go, that looks right. Okay, for this we're going to go hand label and amount, and dealer label and dealer amount. Now, if you're not going to be implementing the cheat system, you can sort of skip this little bit, but I'm just going to add my cheat placeholders down the bottom here. So we'll create let's copy this style here. Can be our upcoming cards. So this will be a list of sort of upcoming cards. Do one here for suggested action. Yeah. Stand or hit. On that's centered. Center those. And on the other side here, and say cards in shoe. Remember, the shoe is just basically the stack of the deck or decks. So that's 0 cards in shoe. There certainly is at the moment. We haven't actually built the shoe yet. And chance to bust. This is like a blind feature, so this would be similar to counting cards kind of thing. So down here I'm going to rename these shapes. Call this cheat upcoming label. Upcoming. I'll just leave it as that. Suggestion. I'll just add a suggestion as well. I'll call it cheat suggestion. Suitable name. Cheat in shoe. And cheat bust chance. Alright, so that's everything we need there. The only other thing that we will need is going to be a cover for our buttons, because when the user clicks something, we're going to have a message come up, and that's going to be a timed message. And if they start hitting extra buttons, then that might sort of interfere with our code. So we're just going to create a cover for the buttons. So we'll just draw a big rectangle over those. Set no outline, and then go to format shape, set the transparency to 100. If you do no fill, then you can actually click through that shape. If you set the transparency, then you can't actually click on the stuff underneath it. If I do a fill, no fill, then I can actually click on that shape. If I leave it as just transparent, it intercepts my click. I'm going to call that cover buttons. Then lastly, we need a message box. I'm going to create another nice big shape. I want that centered on the screen, so I'm going to use this bottom bar as reference. Center it like that. And maybe for this we use a deep green color again. Maybe more like that. And our outline. Big outline, and give it a deeper green. And then our message is going to be something like, you won plus $50 or something like that. Again, we use the same font. We'll center this and we're going to make this big. I think that's big enough. And I think I'll use that orange again, but slightly resize. There we go. So that's everything we're going to need. Now I'm just going to hide that. Oh, actually, I'll just rename that to message. And we'll hide that. Hide cover buttons so that we can interact with these buttons as we need to. Oh, now one more thing that we need to do here just before we move on. We're going to create a collection of cards, right, that are going to be for each player, the player, or the dealer. These are going to be as your dealt cards. That's going to show each of these cards and sort of replace the picture with the card that you've been dealt. So we're going to create a shape. Actually, we can just sort of refer to this shape. And we can make sure that that's centered on the table. Okay, so we'll call this card 1. All right. And we're going to set the user picture of this. So we'll go to Format Shape, go Picture, we'll insert from File, and we'll just refer to any of those cards, okay? I also just want to make sure that we don't have an outline or a shape outline. All right, so that's our card. I'm going to place that in that placeholder spot. And then the most cards that you can have as in a blackjack hand, surprisingly, is actually 11. You can get 4 aces, 4 2s, and 3 3s, and that will give you value 21. So we're going to create a group of cards for each player, which is going to be 12 potential cards. All right, so we'll do 4, 5, 6, 7, 8, 9, 10, 11, 12. It's very unlikely that we'll ever get past, sort of 5 or 6, but this just gives us a number of cards that we can potentially move into. We're going to name them cards 1 to 12. All right, now they're all sort of all over the place, so we're just going to select all of those. We'll align them all. I'll just move those up, and then I'll align them all to the bottom. Make sure that we don't poorly position them, and then we want to distribute them horizontally. So you can see every card value and suit is visible in that list of cards. Okay. Then we're going to group all of those. Let's group them together. And we're going to call that player cards. And we're going to duplicate that, so just copy that whole group. And we can rotate it around because this is going to be the dealer's side. And this is going to be the dealer cards. All right. Let's hide those. And yeah, we're done. I think our entire interface is done, so now we can start getting into the actual code. All right, in our code, we're going to set up the sort of basic structure for this first. So let's go right click, go insert module. We're going to create a mod for the deck. I'm going to create another module for shape handler. And then our last one, this is going to be our mod for the actual game, so we're going to call that Blackjack. And then we're going to have classes. So we're going to have class modules in here. We're going to have a class for the player. And we're going to make cards as their own sort of object as well. So let's card. The first things first, I think we can build our deck. I can show you how we're going to build the deck. So our deck, we're going to have a public deck as a collection. This is going to be the collection used by the rest of the application to say that, you know, that's what our deck entails. We're going to have an enum of our card suit. So we're going to go hearts 0, and then every subsequent one just increases that value by 1. So go diamonds, clubs, spades. Doesn't matter which order these are in, it's just a reference to how things are sort of operated. We do a similar enum for our card values, so we'll go public enum card value. Got ace is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, and we'll end that. So each item you've enumerated is going to increase 1 in value if you just set the first. So the ace is going to be 1, 2 is 2, 3 is 3, all the way down to jack is 11, 10, 11, 12, and 13 for jack, queen, and king. Now next we're going to create our generate deck function. So this is going to return a deck so that we can call this and, you know, create a deck that we can start to sort of play with and like iterate or draw cards from and so on and so forth. So we'll do public function generate deck. Now we'll do an optional by val deck count as long. We'll set it to 1, and then that's going to return a collection. So why do we have a deck count? In a lot of casinos and stuff, they actually shuffle, especially with games like Blackjack, they shuffle multiple decks together. So it's actually theoretically possible for you to be dealt a hand with, say, 2 ace of spades, because you've got, you know, multiple decks shuffled into one. In our game, we're going to use a generated deck of about 4 decks, but this is going to handle that completely dynamically, so we can use it however we need to. So in here, we're going to have a temporary deck as a collection. This is going to be the deck that we sort of fill up in the function itself before we return this to the deck object. We go dim suit as a card suit, value as card value. And then we're going to create a card as a CLS card. Now, before we get any further into the generate deck, we're probably going to need to identify what our class card actually is, because we're building a deck of cards and we need to know what is actually in each card, what properties and everything like that. So let's go into our class card. We're going to need a few properties. We're going to need properties for what the value of the card is, what the suit of the card is, and we'll also need to know whether the card is face up or face down, because the dealer is going to have instances where the card is going to be facing down. We're going to create some private variables here. So we're going to have private p suit as card suit. So this is our enum that we just created in the deck. And private p value as card value. So again, that's the enum we've created here. So just referring to these two enumerated types. And then we're going to have a p face up as boolean. This is going to tell us whether the card is face up or face down. So when our class is initialized, the default state for our face up is going to be true. So we actually want to set that to true. So whenever we create a new card, that card is going to be face up by default. So we're going to need a few properties here. What we can do is actually use the inbuilt procedure builder. So we're going to go property. It's going to be a public property, and this first one's going to be suit. So this is going to be as a card suit, which is our custom enumeration again, and our suit value. So we'll go v suit as card suit. Our get method is just going to set the suit that they've referred to equal to p suit, which is our private variable here, and just the kind of the opposite here. So when we're setting p suit or letting it be a certain value, we're just assigning the new value that has been passed to it to the internal variable. And we're just going to need the same for our value and face up properties. So add those in. We'll do value v value as card value. That. And this one's going to be our face up. Up. Oops, okay. V face up and face up there, and they're just going to be Boolean values, not any sort of fancy enumeration. Now the other thing that might be useful for us is going to be the value of the card in terms of the game, because as I said, the Jack, Queen and King are all counted as 10, but in our enumeration each of those has their own value, 11, 12 and 13. So we're going to create a public property as well. It's just a custom one, get game value. We're not going to do a let for this either, and that's going to be as a long. Now we'll set the game value equal to if p value, the p value is our internal value, is greater than 10, so is greater than the actual 10 card, which is Jack, Queen and King. That value is also going to be 10, otherwise that will just be the value card. Actually, we might even create this as our enumeration, so we'll create that as card value. We'll say if that is greater than 10, then we'll set it to 10. All right. Now the other things that we're going to need are a couple of custom functions. So we're going to need a public function to get the suit name. So the suit name is going to be create a custom little function here to help return that. The suit name is just going to be select case, and it's going to be the p suit. And so for the case of card suit clubs, going to do suit name equals club. So it's just going to be simple like that. We're going to do that for all of our different enumerations. So do diamonds, hearts, spades. And just make them single like that. And end select. And we do the same thing for the card value, or I'm just going to call it the card name. So function card name as a string, and select case p value. So if the card value, if the value is an ace, then our card name is going to be A. And for Jack, Queen, and King, do J, Q, K. All right, and else card, return the card name as just the p value. Okay, so that's everything we need in our card class. So now if we go back to our deck, we can start to actually create our deck, generate our deck. So we're going to set our temp deck. There's a new collection. We have an iterator here as well, I is long. So that we're going to loop from 1 to deck count. This is going to be how many decks we're actually using. Next I. And then inside of that, we're going to go for suit equals hearts to spades. Spades. So that's going from this first enumeration to the last enumeration. Next suit, and we're going to do the same thing for our value. So for value equals ace to king. All right. So now we're going to set our card. So we've got our card object here. We're going to set that card object equal to a new class card. Card suit is going to be the suit we've created here. And the card value is going to be the value here. So we're just iterating over every possible combination of, you know, suit and value and creating them in the deck. And then we add that card into the deck. Now here's the problem. What we've created here is now a deck that is always going to be formatted in exactly the same way, or always going to be ordered in exactly the same way. You're going to have the ace to king of hearts, then the ace to king of diamonds, ace to king of clubs, ace to king of spades, and then do that for however many decks that we have. So we're going to need to randomize our deck or shuffle the deck. So we're going to set our generate deck equal to shuffle deck, and we're going to pass in that temp deck object. Oops, and that temp deck is that one, not that deck. So yeah, we're adding the cards into the temporary deck, not into the public deck just yet. Now, shuffle deck, we're going to need to create that function. So let's do that. So we'll do private function shuffle deck. And this is going to take an input deck as a collection, and it's going to return a collection. So it's basically just taking a deck as whatever the deck is currently sorted as, and then spitting it out as a shuffled deck. Give ourselves a little bit of space here. All right, so we're going to do a randomized deck as a collection. Index is long, random index as a long. We're also going to have a temporary list as a dictionary. We need a dictionary because we need to refer to specific keys. I don't think I have dictionary set up yet, so we'll go tools, references, and we'll just make sure that we've got the Microsoft scripting runtime ticked. So new dictionary, that object is now there. We're going to set our randomized deck. Deck into a new collection. And then we're going to iterate over how many items are in the input deck, right? So we're going to go for index equals 1 to input deck.count. Next index. And all we're doing is filling up this temporary list, so this dictionary item, with each of those items from our index. So we'll do temp list.add. The key is going to be the index, and the input, and the item is going to be the input deck index. So remember, our input deck is a collection. Each item in the collection is a card. So essentially we're just adding each of those cards into this dictionary and indexing them with the index value that we're iterating over. Now here, before we actually create or sort of randomize the values that we're doing, we're going to actually call the randomize statement. So what this does is it just ensures that the randomness is seeded each time the function is called, which prevents repetitive patterns. You know, when you're re-randomizing or reshuffling the decks. So we'll do while a temp list dot count is greater than 0. So what we're going to do is we're going to loop through this temp list and remove things as we go. Okay. So our random index is going to be an integer of the temp list dot count times the random value plus 1. This is just going to give us a random number of the items that are actually currently in the temporary list. We do randomize deck dot add, and we refer to temp list dot items, and the items is going to be the random index minus 1. So this is just getting a collection of the items and then referring to the item in that collection. And then we do temp list dot remove, and we just remove that item from the list. Okay. And we set our shuffle deck item here equal to our randomized deck. And that's all we need to do. So that's now shuffled our deck into a completely random order. So I'll show you how this comes together. So what we'll do is a quick test function. So we'll do sub test deck, do dim, we can just use this deck. Go set deck equals generate deck, and we'll just leave that as 1 for now, just so you can see what's happening. So we'll run that code. That will jump here into the deck. So let's have a quick look at that deck. So we'll go temp deck. This is what we're actually spitting out at the end of this generate deck function. So item 1 here, ace of hearts, 2 of hearts, 3 of hearts, 4 of hearts, and so on. As we jump out of that, go into the shuffle deck. By the end of shuffle deck, we can have a look at our randomized deck item. We can see here now we've got 7 of diamonds, 9 of clubs, 5 of spades, 7 of clubs. So it's completely randomized that deck. And the beauty of doing it this way is now that if we want, we can go, okay, we want 5 decks. So we'll run that, and then you can see that our deck object, we now have 5 times 52 cards, 256 items, and all of them are completely randomized and completely shuffled together. Before we move on to creating our player class, let's quickly set up the shape handler module. Our shape handler is just going to make it easier for us to refer to shapes. So rather than doing sheet game dot shapes button restart or whatever the things might be, we'll just create a function that called button restart that returns that shape, right? So public function button restart as shape, set button restart equal to sheet game shapes button restart. Okay, We're just going to do that for all of our different shapes that we have in our form or in our game, or specifically mostly for the buttons. So I'll just quickly do that. All right, so we've created those. Now, personally, I just find it a lot easier to create a custom routine to handle setting shape text, because that gets messy because you need to refer to the sheet, the shape, text frame to text range dot text equals the text value. So rather than do that, I just make a simple routine that does that all for me. So we'll do public sub set shape text byval shape as string. That's going to be the shape name, and byval text as string. Oops. Okay, so we're going to get our shape name and the text value there. We're going to do sheet game dot shapes shape name there, text frame to text range dot text equal the text value. We'll do the same sort of thing with the visibility of the shape, because we'll need to be setting that on and off with like our messages and stuff like that. So set shape visibility shape and state as a boolean. Actually, we'll set that as MSO tri-state, because that's what the visibility state accepts. Now, we don't want to set our visibility state to something that's already set to. So that just, you know, increases the load on the system. So we just don't need to do that. So we'll do if sheet game dot shapes shape visible does not equal the state we've been passed. Then we'll set the visibility equal to the state. That's it. So that's all we need for our shape handler function, shape handler module. Now let's jump into building the player class. In our player, we're going to have, again, a bunch of private values and private properties that are going to help us sort of use our player and interact with our player however we need to. So we're going to have a private cards as a collection. This is going to be a collection of cards. It's basically the player's hand, right? So whatever cards are in the player's current hand. And we're going to have a private max wager as integer. So this is going to be more used by the dealer, because the dealer, by default, they won't let their hand go over 17, right? Unless obviously they draw higher than 17. But 17 is where they sort of limit themselves, so that's going to be where we set our max wager. Then we're going to have a private is busted as boolean. That's basically returning it to tell us if the player has busted, if the player is standing, the card group. Now, if you remember when we created our shapes in the worksheet, we've got that group of cards that are sort of all hidden. So we can we need to assign which group we're referring to when we're creating our player, or because the player can be either the player yourself or the dealer. Going to have that as a shape. And private P wins. It's going to be a long, so this is just going to hold where we have how many wins, losses, and ties we have. And then we're going to have our bet amount as currency and our balance also as currency. All right, so now we've got all of our variables in there. We need to initialize our class. It's going to set up our class, so we're going to do set our P cards as a new collection. So going to initialize that collection, and then we're going to set a bunch of default values for our player, right? So as we create the player, they're not going to be busted, are they? So we'll do is busted equals false. They're not going to be standing, so we'll do stand is false. The max wager by default should be 21 because that's the most cards that you can have. Again, this will be manually set for the dealer and it won't really apply to the player, but we should just set that as a default value. Our wins, losses, and ties should all be 0. And then our player balance should also be 0. Okay. One of the key things that we're going to need to do is to add cards to our hand, right? So let's do a public sub. This is going to be called from outside, so we need to make sure that's public. And add card. So it's going to accept a card as a card class or a card object. And all we need to do for that is go cards.add. So this is our cards collection for the player. A card. And then we'll do if, and we'll create a get total routine in just a second. If that's greater than 21, then we set P is busted equal true. So basically, if the player gets a card, their new total is now over 21, then they've busted. And we want to show which cards they actually have. So we haven't got these two functions yet, so we'll build them now. So we'll have a public function of get total. This will be referred to internally and externally, so we need to make sure that that's publicly accessible. And that's going to be returning as a long. So we're going to be looping through each card in the player's hand. So we'll do a card as a class card and the total as a long. So this is going to be the value that we add to as we loop through each card. So for each card in P cards, which is the player's hand, next card, we'll do if card.faceUp because we don't want to calculate and display the value of cards that are face down. So if card face up, then and if total is going to be equal to the total plus, so if the card dot value equals ace, because remember the ace can be either 1 or 11 depending on what's better for your hand. So by default we're going to do if the card value is ace, then we'll set that to 11, else the card is going to be equal to the game value. Now, the game value, if you remember, that sets it so that if it's a jack, queen or king, then that's going to be 10. Otherwise it's going to be equal to whatever the card is. Okay, and then because we've got this, right? So if our card is an ace and we're adding 11, but what if 11 isn't actually the best thing for our hand? So we're going to do if our total so far is greater than 21, then we're going to loop again through each card. So for each card in P cards, next card, and if that card value is an ace, then we're going to take 10 off of our total, right? So if our total is less than or equal to now 21, then we can exit that for routine. So if the player has more than one ace, then that's going to reduce only what it needs to reduce to get it under 21 or equal to 21. Okay? And then lastly, we just return that get total as our total internal value. All right, so now we have a function to get the player's hand value. So we can see now as we add a card, if we get the total of the player's hand, and if that's greater than 21, then we can tell the player is busted. Next thing we should build is to actually show the cards in the player's hand. So for this is only going to be private because we're only going to be calling this internally. So we're going to show cards. We're going to do, again, card as class card because we need to iterate over the number of cards that the player has. So we'll do for each card in P cards. And we'll increase the iterator by 1. So then we set the card picture. Again, this is something that we haven't created. We'll create that in just a moment. That's going to accept our P card group. Remember, our card group is the group shape that we've assigned, which we haven't assigned yet. That's going to be when we initialize our game, but that's going to have our card group, which is going to be, you know, this group for our player or this group for our dealer. Okay, so we're going to be referring to that card group. The group items is I, and we're passing the card in. So we're making a routine here that accepts a shape. So we're referring to a group item from this group, which is going to be a shape. We're going to get the value from that card, the value and the suit from that card, and assign it to that shape. And we're going to be able to refer to that by referring to our card table that we built before. So next we can do p card group dot group items as visible equals true. So this is setting our card picture, and then this is making that card in the group visible. And finally, what we want to do is for whatever we've left off on this, as we're iterating over each card. So I equals I plus 1. So if we've got to, say, the third card, and we've set all the pictures because they're the cards that the player has. So we've looped through 3 cards in their collection. We've set 3 cards to visible and shown the picture of each of those 3 cards. Then we want to start at the 4th card, so I will be 3. So we'll go from I to 3 plus 1, and then go to the amount of group items that we have. So p group items dot count, and then we're just going to make sure that the rest of those aren't visible, because if we only have 3 cards, 4 onwards don't need to be seen. So now we need to create this set card picture routine. So let's just quickly do that. So private sub, set card picture. That's going to accept a card shape as a shape. And then a card as class card. Alright, so first we need to check if the card is face up. If it's face up, then we're only going to be showing the card back, right? So if the card is face up, then show card face, else show card back. So we'll quickly do the back routine because that one's nice and easy. So we'll do the card shape dot fill user picture, and then for that we're going to refer to sheet cards range and card back, and we refer to the formula. Don't refer to the value. The value comes through as, I think, a blank or an error or something like that. Refer to the formula because the formula is going to actually have the path to our card. So remember, as look in here, the card back, so this is our card back cell. Formula is going to return this value. All right. Now we need to do the same thing for the face, but we need to find out which card we're actually referring to first. So we'll do dim table as list object. So list object. We'll set that table equal to sheet cards, list objects, and table cards. So that's this table here. You see table cards there. And we need to loop through each row, so table row as list row. So for each row in table.listRows, if the lowercase of table row range 2 is going to be the item in the second column, so we're looping through each row like this, and then we're looking at the second column, so this. So if that equals card.suit name, and we'll make both of them lowercase so that we're comparing similar strings, and we want to check if the value is the same, so we'll check lcase table row range 3. Again, 3 is our card here, and check if that one is equal to the lcase card name. Alright, so if we've got hearts, if the card is hearts and we've landed on the hearts row, and if the card is a 2, for example, and we've landed on the 2 row, then we need to grab that formula and do the same thing as we've done down here. So we fill the user picture with table row dot range 4.formula. We use 4 here because we've got 1, 2, 3, 4. 4 is the image formula. So now we've set the card picture, so in here in our show cards, you can see we're iterating through each card in the cards in the player's hand, and we assign the image from that card picture to that shape, make that visible, make every other shape invisible, and then we can move on. So now we've got our add card is done. So our add card, we add the card to our hand, we get the total, check if the total is greater than 21. If it's greater than 21, the player is busted, and then we show all the cards in that player's hand. Now internally, we're also going to want a hide cards routine, so we're just going to do basically this, right? Private sub hide cards. This is going to be when we're resetting the player, okay? So let's do basically that. We'll loop through every card in the player's hand and just make them invisible. That's going to be another thing that we need in there. All right, next we're going to build out all the properties that we need for this class. So we'll have a public property, which we only need to get, right? Which is going to be our wins. We're going to do the same for, wins is p wins. And then we're just going to do the same thing for our losses and ties. Ties, wins, losses, and ties. And we need a property for the player's bet. So we're going to have a public property. Let the bet by val bet value. So the bet value as currency. We're going to set the p bet equal v bet value. I'm going to do the get for that one as well. And that's going to say the bet is equal to p bet. Okay, and the same sort of process we're going to do for the balance. And the player's current stand state. And then the max wager. Again, this is only going to be used for the dealer. And just a couple more. We want the player is busted. And then we want to just be able to get the cards collection, because we'll need to refer to those outside of the class. So we'll do set cards as p cards. And then the last property is going to be setting that card group. So we're going to do public property set, not let, set card group equals by val the shape group as shape. And then we're going to set the p card group equals the shape group. Okay, so properties are always just going to be very simple, non-calculative, just passing variables in and out. You can reduce the need for all this by creating these as public variables, but this way you have a lot more control over how these are handled, so it's much better practice to use. I'm going to move them right down, get them out of the way. Then we're going to need some simple routines just to say if the player won, lost, or tied, or if they're blackjack. Let's just create those. So public sub won, public sub lost, and public sub tied, and public function is blackjack. I'm just going to return true or false value. So if we won, then we're going to add that to p wins plus 1. So we're just going to increment our wins value, and that's just going to be the same thing for our lost and tied. So losses and ties. Our blackjack, we're just going to return is blackjack equals, so if our cards, if we only have 2 cards in our hand, because you can't blackjack unless you've only got 2 cards, so you've been dealt the first 2 cards and that equals 21. So if the cards count is 2 and get total is 21, then you're blackjack. If one of these is not true, then that's going to make that false. Okay, so we only need a few more things now. So we're going to want to make sure that we can reset our player. Okay, so on public sub reset, we're going to be able to reset our player or our dealer depending on who's called. We set p cards as a new collection, so we'll reset the player's hand collection. Do is busted equals false, stand equals false, and we'll hide all of their cards. If we're resetting it, it's maybe a new hand, so we need to reset the player, we hide all of their cards, and then give them new cards and show their cards again. Next thing we're going to need to do is when the dealer, when it's the dealer's turn, they need to be able to turn their cards up. So we'll just create a function to turn all cards face up. Okay, so do public sub turn cards face up. And again, we'll iterate through the cards. So I equals I plus 1. Do card.face up equals true. And we'll do set card picture p card group items 1 and pass that card in. Okay, so that's going to turn all of our cards face up. So if the back is currently shown, it'll turn that card back face up so it shows the face card again. And the final thing we need is we need to know if the player or the dealer rather should stop. So that's going to be a nice simple function that we'll return. So public function should stop as boolean, should stop equals get total is greater than or equal to the max wager or is busted. Right, so if the total of the dealer's hand is greater than the max wager is going to be set to 17. So if their total is greater than 17 or they're busted, then they need to stop. All right, and that's it for our class, for our player class. Now we can actually build our game, and we can actually start, creating the Blackjack game itself and start playing with it, make it usable. Let's just do a quick compile, make sure everything's working. So P balance, I've typed everything properly. The cards should be, there we go. Okay, so our class is now complete and ready to start using. Now we can finally actually get into coding the game. In the game, we're going to have a few game sort of entities, variables that we use. All right, so we're going to have a private player as class player. Probably guess we're also going to do the dealer, so class dealer. Class as a player as well. Private game state, as we're going to create a custom enumeration, so e game state for that. And that's going to be private enum e game state. All right, and we'll fill that out in just a second. There's going to be a few configuration sort of things that we can set up for ourselves. Okay, so we're going to have private constant show cheats. Now, whether you actually have the cheats or not is completely up to you. I'm going to set them to off to start with. If you didn't set up those shapes on the game interface, then you won't be able to use the cheats. Private constant max bet as currency. We're just going to set this to a huge number, right? The player can't exceed that bet. At the moment, we don't want to sort of give them a limit, so we'll just give it a nice big number. Const the minimum bet, we don't want them to be able to bet any less than $1. We'll set it to 1. Then we'll do dealer max wager as long. We're going to set that to 17. So the dealer's maximum hand that they're trying to sort of reach is going to be 17. That just makes it so that you can set that and play with different options and things. Then we'll do the player start balance. This is going to be the balance the player has when they first start the game. So we're going to give them $100 to start with. We have reshuffle threshold. We're going to set that to 15. So that's basically saying if there's less than 15 cards in the deck, then we need to reshuffle the deck, or generate a new deck using the generate deck from our mod deck. We're going to have a private constant for the message timer. As long, we're going to set it to 150, and private constant deck count. This is going to be how many decks we actually use, so we're going to set that to 4. All right. So different game states. We're going to have 6 different states. We're going to have not ready. This is going to be when the game's not initialized properly. We need to do a ready one when we're dealing, when it's the player's turn, it's dealer's turn, and when the round is over. They're going to be our 6 game states. Remember our enumeration, if you start at 0, each one is going to be incrementally given a new value. All right, so the first thing we need to do is when we're actually going to be initializing the game. So this is going to be when we click the restart button. That's going to initialize the game and set it to its ready sort of state. So we're going to create a public sub for the button restart click. So I'm going to use a bunch of different sort of references in here to different routines that we haven't built yet, but we'll sort of build them out. So the set game state is not ready at the start. Well, we want to make sure that our sheet is protected so that when the user doesn't have, like, if we look here, we can still see that we can click in cells. We don't want this. This is, it takes away from the immersion that we're in a kind of a game or something like a game, even though we're in Excel. So we'll stop the user from having this. We want to protect the sheet, but we only want to use user interface only. If you don't do this, then when you're adjusting shapes or doing different things, different values and things like that, then that's going to cause an error. This means that the code can still interact with those elements, but the player or the user can't. Then we're going to set our deck. So set deck equal to a new collection. That's going to initialize our deck. But for now, we're not actually going to be generating that, because that's going to be when start or deal the hand. We'll set our player equal to a new player and set the player's card group. Card group equal to sheet games shapes player cards. Remember, this is our group of shapes we've got here for the player cards and the dealer cards. So before I go ahead, that message should definitely be above those cards. Okay. So we've set the player card group. Now we want to just make sure that the player is completely reset. That should be the case anyway, because we're resetting or instantiating the player, but we'll just do that reset just as a secondary sort of precaution. We'll set the balance equal to the player start balance that we had up here. Now for our dealer, we'll do set dealer equal to a new player as well. We'll set the dealer's card group. It's going to be the same as this. Dealer cards. And then we'll do dealer max wager, and we'll set that equal to that parameter we've assigned up the top. And reset the dealer. Now that everything's kind of set up, we can set the game state to ready. We're going to set our player bet equal to 1. So that's just resetting the player's bet back down to its sort of initial state. Actually, we can set that equal to the minimum bet rather than 1. We're going to change bet 0. We're not actually changing the bet, but this is going to do some things. Then we display scores, display balance, and display a blank message. Alright, so that's that. As I said, there's a few functions in here that aren't really going to make sense, but I'm going to sort of go through all those now. So our get set game state, this is going to be sort of a pretty important one. So we're going to set that first. So we'll do private sub set game state by value state as e game state. So this is our custom enumeration here, basically this stuff here. So first of all, we're going to set our private variable of game state equal to the state variable. We're going to display the relevant buttons for that game state, and then if the game state equals the dealer's turn, then we need to finish the hand. If the game state is round over, then we need to evaluate the game. Okay, again, we've got a few routines here that we haven't created yet, but we'll get into those. This display buttons one is going to be where we display the relevant buttons to the current state of the game. Okay, so we've got private sub display buttons. So the relevant buttons that we've got button restart, got button deal, button bet up. Remember, these are the buttons that we referred to in the shape handler. Button bet down, button bet up 5, button bet down 5, button bet all, and then our button hit and button stand. So we're going to set the visibility of these. So visible equals, and in here we're going to do if the game state equals not ready, or the game state equals ready. So we can just set the visibility of that equal to whether the game state is not ready or it's ready. So we only want the restart button visible when the game is not ready or it's ready. We don't want it to happen in the dealer turn, in the player turn, or when we're rounds over or anything like that. So the deal is going to be only available when the game state is ready, and that's going to be the same for all of these bet options as well. For our hit and stand, that they're only going to be available when it's the player's turn. And that's it. So that's our display buttons function. Now these ones aren't going to make a lot of sense if I go into those now. So we'll go into the other components first. So we'll go into where we deal card. Right. So we'll do a public sub for button deal. Click. Then this will do if the game state equals not ready. Then we need to set the game state equals to not ready. Because if it's not ready, then we're showing the relevant buttons, right? And after that's done, we exit the sub. Once we do that, we set the game state equal to the player's turn. Because if we've pressed deal, then we're starting the player's turn, and we're going to deal the initial cards. So deal initial cards. So the player's balance equal to the player.balance minus the player's bet. So this is basically taking their bet out of their balance, so that when they say you've got $100, you've bet $10. You start the round, that $10 is now gone, so you've only got $90. But what you get back will be either 2 times your initial bet, depending on if you win or lose. Alright, so we set the balance, then we'll display the scores. Display the balance. Actually, in here we'll do if the player is Blackjack, because when they first dealt their cards, and if they get Blackjack, then the round's immediately over. So set game state equals to round over. So this deal initial cards, this is going to be where we actually sort of start to deal the cards to start the game. So we're going to put that as a private sub, deal initial cards. And first we're going to check if the deck count is less than or equal to the reshuffle threshold. Then we set the deck equal to generate deck. Equal to generate deck with the deck count parameter. Okay, so when we first start, the deck count is going to be 0. It's going to be an empty deck. So we're going to, that's definitely going to be less than our threshold. So if our deck count is less than that threshold, then we set the deck equal to generate a new deck. So we've got a new shuffled deck with, in our case, we've got 4 decks all shuffled together. And here we're going to reset the dealer, reset the player, and the dealer, add card. We're going to deal a card. Again, this deal card isn't going to make a lot of sense yet, but we'll get to that next. So we're going to deal a card to the dealer, deal a card to the player, this is going to be the face up value of that card. So the first card that the dealer's dealt is going to be face down. So it's going to be face up equals false. So that's going to be face down. And then want to add, so the dealer gets the first card, then the player, then the dealer, then the player. So the player gets 2, dealer gets 2. Only the first card of the dealer is face down. All right, so if you remember this add card routine, right? Add card, it accepts a class card. So we're going to need to create this deal card to return a class card object. Okay, so we'll do that now. So we'll do private function deal card. We'll have an optional bival face up as boolean true. We want face up as default, and then we can set the face down value if we need to. And that's going to return a class card. So in this, we're going to have a card object, so as dim class card, if deck.count equals 0. So we just need to make sure that if the deck isn't completely empty, by the time it gets to this, it should never be 0 anyway, because this is always going to trigger first. But this is just a caution just in case. So set deck equals generate deck count, and if. Right, then we need to set that card equal to the first item in the deck. So that's pulling the first card off the top of the deck. And then we need to remove that card from the deck. So deck.remove the first item in the deck. So we've just pulled the card off the deck and given that, grab that as a card object. So card face up to the face up parameter that we passed in. And then we set deal card equal to that card object. All right, so when we do add card, we deal a card to the dealer. This is going to be face down. That goes and grabs the first card from the deck, makes it face down, and returns that so that that's now in the dealer's hand, and does that for the player, dealer, and then the player again. Okay, so that's our deal initial cards. I think the best thing to do now is to do the hit and stand buttons, because they're going to be quite simple. So we'll do public sub button hit, click, if game state equals not ready. So we'll just do the same thing up here. This is just in case the game state crashes or something, it's returning to the not ready state, so we'll just reinitialize the game. Then if they're hit, then we're dealing them a new card, so we'll do player.add card deal card. Okay, then we just need to display the scores, and if the player is busted, then set game state to dealer turn. Alright, that's all our hit button is going to do. Then our stand button, so public sub button stand, click. Again, just need to double check that the game is actually ready. Set the player to stand is true. And then we'll set the game state to the dealer turn. Alright, so that's all of our sort of primary buttons done. Now we're going to do the function where in the game state, we set the game state to the dealer's turn. We need to finish the hand, right? So we're going to finish hand. So we're going to do that next. So private sub finish hand. So for the dealer, once it goes to the dealer's turn, we need to have the cards go face up. So turn the cards face up for the dealer. And we display the scores. This is going to then show the dealer's current hand. And we do while not dealer is busted and not dealer should stop and not player.is busted. Okay, and we loop. So in here, we're going to loop through and issue the dealer a new card each time. If, once the dealer is busted, then it's going to exit out of this loop and finish the turn. So we'll do events, because we're doing a loop where we want to actually display things to the user, and we'll do an application.wait. Now time value. So basically we're going to wait 1 second between each card being issued to the dealer. That's just going to give the effect of actually dealing a card one by one, rather than just suddenly the dealer's completely dealt. We'll do dealer.addCard, deal card, and then display the scores. Then finally, once the dealer is busted, should stop, or the player is busted, then we set the game state equals round over. Now, in the game state, once the round is over, we need to evaluate the game. So evaluating the game is going to basically give us the game result. So has the player won? Has the player lost? Has the player blackjack? Has the dealer done a backflip or whatever? So let's do that then. So private sub evaluate game. Going to have a variable for the amount the player has won as currency. The message text, because we want to display a message once the game's finished. String. We're just going to do a bunch of if statements and then go to this end game label once it's jumped into each of those. So if player.is blackjack and not dealer is blackjack, then the amount won for that is going to be the player's bet times 2.5. If they're blackjack, then that's the best hand. They get the highest payout from that. So that's going to be 2.5 times their original bet. Message text for that is going to be, we'll say player blackjack. And on a new line, we'll tell them how much they've won. They'll go 1. And we'll format amount 1 as that of a format. We're also going to say the player won, so that's going to increment the amount of wins that they have, and then we're going to go to the end game label. Then in the chance that the player is busted, so if player.is busted, and we're going to do a similar thing here, but the amount won is going to be 0. I'm going to say player busted. I'm going to say they lost the player.bet amount. And we're going to say the player lost. All right, then that's going to jump down to the end game label again. And then we have if not dealer dot is busted. Oops. So that's indented properly. All right, we're also going to have an else statement in here for this. So if the dealer is busted, then it's going to come down here. The player won't be busted because it's already past this, and it's said that the player hasn't busted. So the amount won is going to be player bet times 2. So yeah, if the dealer has busted, then the player wins essentially. So we'll do message text player won, and we'll say they won the amount won. Player.1 and go to end game again. Okay, and then we're going to have if if the dealer isn't busted, then the player get total is greater than the dealer get total. Remember, neither of these are going to be over 21, because if the player was over 21, then they would be busted, so they wouldn't have passed here. If the dealer was over 21, then the dealer would be busted, so they're going to jump down to here. So this already assumes that both the dealer and the player aren't busted. So now we can just say if the player's total is greater than the dealer's total, that means the player won. So we'll copy that from down here. If the player.get total equals the dealer.get total, so they tie, then we're going to have the amount won equals the player bet, so it's just going to return the initial bet back to the player. So we'll say player tied, and the value is pushed back to the player. And we'll give them, so the player tied. That's going to increment the tied amount. And then the last one is going to be if the player total is less than the dealer total, then the amount won is going to be 0. So the player lost, and they lost is going to be the same as up here, and player.lost. And that's it. That's all the possible combinations of whether the player won or the dealer won or the player lost, dealer tied, anything like that. In the end game here, we're going to first just make sure, because the game's over, we want to make sure that the dealer's cards are turned face up. So we'll turn the cards face up. We'll display scores again. Player.balance equals player.balance plus the amount won. So if they lost, then that's going to be 0. And remember, the bet amount was already removed from their balance once they dealt the cards. So if they were on $100, they bet $10, their balance was now $90, they lost. We're not adding anything back to that $90 if they lost. If they won, they get 2 times that, so they go up to $110. If they blackjack, they get 2.5 times that, so they go up to $115. That's how the sort of balance works for the players. Then we're going to display the balances. We're going to display the message. We haven't made this function yet, but we'll get to that. The player bet equals, we want to make sure that the player's bet doesn't exceed their balance. So we'll do player.bet, player.balance. So if the player's balance is, $5 and their bet was $10, then it'll set the balance to $5. But if their balance was $20, it'll leave their bet as it was. And then we change the bet to 0, by 0. We'll get to that again in a minute. If the player balance equals 0, then that means it's game over, the player's bankrupt. So we'll do display message, player bankrupt, and please start a new game. And this display message is also going to have a permanent state, so we'll have that as true as the permanent state, and we'll set the game state back to not ready, which is going to mean that they only have the option to restart the game. If the player balance isn't 0, then we can set the game to ready. We might even make sure, capture all sort of case, if the player balance is less than 0, not that it should ever happen, but just to be sure. Now we've got all these display scores, display balance, display message. We haven't actually created any of these routines yet. I think that's going to be the next sort of most important thing to do. So we're going to do private sub display balance. So in here, we set shape text. This is what we created in the shape handler, set shape text. So this is just an easy way for us to set the text of that shape. And we'll do set shape text of the balance amount. The shape for that going to be balance amount. Format, player balance, and we'll format that like a nicely formatted currency. That's all that one needs to be. The display scores, so private sub display scores. The scores is going to be the player's hand size as well as whether the player, how many times the player's won, lost, tied, and so on. This will also call the cheats, so we're going to create display cheats as well to show you how we're going to actually, how the player could potentially cheat. So set shape text, and we want to do the hand size, so the player's hand size and amount. And do if player is busted, player.get total and bust, else just show the total. Then we're going to do the same thing for the dealer. Dealer amount. If the dealer is busted, do the same sort of thing. So it should have a close bracket at the end of that. Then we want to display the score for wins, losses, and ties. Should not have that there. It's going to be wins amount, losses amount, and ties amount. Okay. So set shape text, wins amount, player.wins. Nice and easy. The same thing for losses and ties. Player.losses and player.ties. And then we're going to call display cheats. This is going to be something that we'll create right at the very end of the video. I won't get into that right now because that's sort of like an option extra. Then we're going to have our display message. So private sub display message. We're going to have bival. This is going to be the text that we want to display. Then we're going to have an optional bival permanent as boolean equals false. Now the first thing we'll do in here, we're going to want to disable the buttons, right? To disable the buttons, remember that cover for the buttons that we created. So this one, cover buttons. All we need to do is just show that, okay? So we're just going to set shape visibility of cover buttons equals true. And we're going to dimension a shape as a shape. I'm going to set that shape equal to the message shape. So that's going to be this big shape here. All right. So with shape.textFrame2.textRange, text equal to the text that we've been sent. Font fill transparency equals 0. Do shape fill transparency and the shape line transparency. And finally, we just want to make sure the shape is actually visible. Equals true. So if not permanent, so if the shape isn't permanent, then we need to do something to actually end up getting rid of it. Is permanent, then we're not going to end up getting rid of the shape in the first place. So if the text doesn't equal nothing, then we need to actually show the message. Once the message has been shown, then we set its visibility equal to false. And what we want to do is loop through, so we'll dimension I as long, and we'll loop I equals 0 to message timer. What this is going to do is set the font fill transparency equal to I over the message timer. You can do the same thing for the shape fill and the shape line. And do events means that it'll actually display it as it's reducing its visibility. Then once this is all over, then we can uncover the buttons again. Set shape visibility, it was false. Alright, so that's how we display our message. Now let's just do a quick compile to see if there's any issues. Game could be. Change bet. Oh yeah, we haven't created that yet. Alright, so we'll get onto this one next then, so the change bet. Do that after our buttons, so private sub change bet. That's going to set by val amount as long. So first we're going to say player.bet equals player.bet plus amount. So if we're changing the bet by 1, then that's going to increase the player's bet by 1. If we're changing the bet by 5, then that's going to change the player's bet by 5. In these instances where we already set the player's bet, if we change it by 0, then that just triggers this without actually changing the bet. Alright, so then we do player.bet, and we need to check it against our minimum and maximum bet values. So we'll do application.max player.bet and compare that to the minimum bet. And then we do the same, sort of the inverse, so we do the min, comparing that to the maximum, okay? And then finally we double check that the bet hasn't gone past the player's balance. So do player.bet equals application.min player.bet and player.balance. And then we can just set the shape text of the bet amount is like that. This one here. Set shape text bet amount equals format player bet $0 like that. Alright, what's next? We'll do a debug, display cheats, ignore that one for now, and everything else should be pretty much working. We'll still have to actually create the buttons for changing the bet, so we'll do that now. Do public sub change bet click. Now this is actually going to accept a by val amount long. Now this is going to be our click event, and this is going to have a parameter. I'm going to show you how to actually create a parameter when you're calling or when you're clicking a button. So what we're going to have is the bet all is going to say 999. So we're going to say if the amount equals 999, then the player.bet equals the player.balance, and then we change bet 0. So that's just going to call this and then compare all these and set the bet amount to this, right? If it's not that, then we change bet by the amount. All right, that one routine is going to handle the click events for all of our betting buttons. So let's go and actually start to create all of these click events. So I've got the restart button, assign macro, button restart, done. The hit macro, assign button hit, done, stand, button stand. We also have the deal button, which is currently hidden. Assign macro, button deal. Now, how do we actually make these pass a parameter to that routine? So we've got the routine that's going to be called change bet click. In here, we'll go assign macro. We'll do a single quote, put the routine name there, a space, 1, and close the single quote. That's going to pass the value 1 to that routine. I'm going to copy that. This one, do the same thing, except we'll do -1. This one we'll do -5. This one will be +5, so we'll do 5. And bet all, that's going to be the 999. Okay. Now these should all be reasonably functional, so let's take a quick look and see what's happening. We'll do... Alright, so one thing I forgot to do here was actually set the visible state of all buttons. Right, so they're done. So let's go try again, restart. There we go. So we've now initialized the game and we can start to bet. So change those bet amounts. That will never go below 1. We bet all. That should set it to $100. We can't go above that, but we can reduce the bet again. And if we deal, that's not showing the player's hand. So let's just see what's happening. So we'll unprotect the sheet because we didn't protect that. There we go. So those two need to be actually visible. Just the internal cards in that shouldn't be visible. There we go. We've got our hand as 19. I'm going to stand. I'm going to deal the dealer. The dealer got to 18. So I beat the dealer. I won. You see our wins incremented by 1. My balance increased by 50 because I bet $50. Let's just go all in. We'll bet all again. We'll go deal. And I got blackjack. Did not plan that. We'll try again. We'll go bet all, deal. Hand is 18. We'll stand. We tied with the dealer. The dealer got 18. We got 18. So that increased our ties. And I'm going to make myself bust on this one. So we'll do 18. Hit. We definitely busted. And there we go. Player bankrupt. Please start a new game. See that shape's not quite wide enough, so I'll just make that a bit wider. Get that picture. Make sure that restart button is covered as well. There we go. Then we can restart, and we've got a new game. And now you can actually play the game. And there you have it. Your game's actually now functional. You can see when we deal, didn't blackjack again, the dealer has one card that's face down, one card that's face up. It only shows the value of the face up card, but it shows the value of our entire hand. As we hit, we get more cards, and it increases the hand value. Stand, the dealer doesn't pass 17 because that's what we've set their max wager to, so they don't deal any further. I got to 21, player 1, because I got 21 when they got 20. That was a very risky play, but you get the point. And we can reset the game, sets our balance back to the default, sets our bets, everything like that. And that's basically our operational blackjack game in Excel. Now, there are still these cheats down the bottom, so we'll quickly get into that and show you what the code is like for those. So uncomment that, display cheats, and we're going to create that routine. So private sub display cheats. Now, all of this is obviously going to be within our sheet game. There's going to be quite a bit to change, so we're going to just do with event there. We'll do set shape visibility, and we're going to set the visibility of all of these different items down here. So I'll make sure I unprotect that. This one is cheat upcoming. So upcoming, and the label. And the value for each of those to set the visibility is going to be the show cheats variable. So at the moment that's set to false. When we set it to true, that's going to show all these cheat labels and shapes. Shape is spell properly. There we go. So if show cheats, then we're going to want to do a few things. So if the deck count is greater than 0, then regardless of whether the deck is filled or is not filled, we're going to set the shape text of the in shoe to the deck count. So we'll do set shape text with it sheet in shoe, and we'll do deck count. All right. So regardless of whether there's cards in the deck or not, that's going to show us how many cards are in the deck. You set shape text in here. So this is going to be our bust chance. So this is going to be this shape here. In here we're going to do format bust cards. So we're going to create a function that calculates how many cards will make us bust in the current deck. And divide that by the deck count. And that's going to be a percentage, so we're going to format that as a percent. Next we're going to do set shape text, the suggestion here. So if player.get total plus deck 1 dot game value. So the first item in the deck, so that's the very top item or the next card, we're going to get the value of that. So if the total of the player plus the next card's value is greater than 21, then stand, else we want to hit. Right? So if the player's total plus the next card is greater than 21, we don't want to draw the card. Otherwise, we can safely draw. So it doesn't matter if we're on 20. If the card on the top of the deck is an ace, then that's going to tell us we can hit. And then the next one is going to be the upcoming cards. So this is going to get us a list of upcoming cards. So we'll do set shape text, and we're going to create a routine to grab those. So upcoming cards. I'm going to do the same thing in here, except we're just going to make this going to be a format 0. Suggestion is going to be nothing. Upcoming cards is going to be nothing as well. So these are what's going to show if the deck is empty. These are what's going to show if the deck has got some cards in there. and it's always going to show the deck count. So we're going to create a quick function for bust cards. So we'll do private function bust cards as long. That's going to give us basically an amount of cards that's going to make us bust that are currently in the deck. So card as last card for each card in the deck. You're going to say if player dot get total plus the card dot game value is greater than 21. So it's going to say, it's going to loop through each card and it's going to count how many cards are going to give you a result that's going to make you bust. So we'll say bust cards equals bust cards plus 1. Okay. So when we get the bust chance, that's going to say, all right, there's 50 cards in the deck. 10 are going to make you bust. So that's going to give you a percentage of, like, what's that, 20%. It's going to say there's a 20% chance that you will bust. And then we're going to do a routine or a function that's going to get the upcoming cards as a string. So we'll do private function upcoming cards. And we're going to have an optional show max. So it's going to be how many cards will actually show. And the default for that I'm going to set to 7. So it's going to show 7 cards coming as string. Again, we're going to loop through the deck. So deck dim card as, and we're going to also grab I. So for each card in the deck, you increment I. If I is greater than show max, then we exit the loop. Otherwise, we do upcoming cards equals upcoming cards, and the new card name, and append those onto each other. Then we just want to get rid of that trailing comma, so we'll do upcoming cards equals, we'll say next, so that they know that the first one in our little list is going to be the next card. Upcoming cards length of upcoming cards -2, because we have comma and a space, so we get rid of 2 from the end of the card string. All right, so let's see what those cheats look like then. So we have to obviously turn cheats on before they'll work. If we restart, cards in shoe 0, let's deal. There we go. So we've got 204 cards in the shoe, and it says we've got a 92.16% chance to bust. So this is completely blind. This is basically akin to counting cards at a casino. But we can see here the upcoming cards. So we can see the next card is a 9. So it's telling us that we need to stand. All right. We deal again. We got 16. We got a 60% chance to bust, but we know that the next card is a king, so it's going to tell us to stand. Normally, we might actually bet at the hit on this in this kind of situation. So we've lost, but you can kind of calculate this because we know that the dealer. We can calculate this before we bet. We know the dealer has 1 card, then we're dealt 1 card. Then the dealer, then us. Okay, so this king is going to be the dealer's, the 2 is going to be ours, the ace is going to be the dealer's, 9 is going to be ours. So the king and the ace, that's going to actually make the dealer blackjack. We're never going to win. So in this case, you'd want to bet the absolute minimum, deal. You know, we can hit if we want, stand, but we know the dealer has blackjacked. All right, so now the dealer's going to get the 4 and the ace. We're going to get the 6 and the jack. So we can deal. We know that the next one's going to be a 3. And if we do 3 again, that's going to make us up to 22. So we're going to bust. So we need to stand. And then the dealer only gets to 18. So we win. So you have a much higher chance, obviously, if you pay attention to the information you're given, to make informed decisions. Although, you know, this isn't obviously something that you'd have in a real game, but it's interesting to see how you can grab that information. And that's it. You've built a complete working blackjack game in Excel using VBA. Thanks so much for sticking through the full build. Whether you followed along or just sat back to see how it works, I hope you picked up some useful techniques. If you enjoyed this, please consider giving it a like and subscribing. I've got more VBA and Excel builds on the way. And if you'd prefer this tutorial broken into shorter episodes, the full series is linked below in the description. As always, the final product is available on my Patreon for one-time purchase or for free to second-tier members. Thanks again for watching. This is your VB Tutor signing out.